Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 9th, 2025, about 4 days ago. The big headline is that this paper introduces R-horizon to stress long-horizon reasoning and shows that training with these composed tasks via reinforcement learning lifts accuracy by 7.5 on AME 2024. The paper is titled R-horizon: How far can your large reasoning model really go in breadth and depth? And the implications for model training are quite significant. Beyond the gains, the study reveals sharp degradation on multi-step tasks and diagnoses limits in effective reasoning length and token budget allocation. Also, the authors shared a full GitHub repo. You'll find setup and requirements, evaluation scripts with config and run.sh for LLM serving, benchmark datasets download, and scoring. There are training scripts for RLVR and GRPO, plus dataset construction tools that compose multi-step problems. The README walks through installation, usage, and examples. Alright, Figure 1 shows that real accuracy collapses as the composed query count grows, while a theoretical estimate declines more gently. Theoretical accuracy here means an independence product of single problem pass rates, which sets an optimistic ceiling. The left column tracks math sets, the middle covers AIME, and the right shows contest-style math. Across models, the gap widens dramatically because errors compound across dependent steps. So, while Figure 1 showed collapsing accuracy with longer chains, Figure 2 presents the R-horizon pipeline that turns single questions into dependent sequences. Query composition here means later problems require earlier answers, and the top row illustrates direct, sequential, and graphic composition. The bottom left panel outlines the long horizon benchmark across 6 tasks with typical failure modes. The bottom right panel depicts training data for reinforcement learning that uses a verifiable reward, granting success only when all sub-answers are correct. So Figure 3 shows accuracy collapsing as the composed query number increases. Composed query number means the horizon length, where several dependent subproblems must all be correct. On AIME 25, DeepSeek R1 falls to about 25% at 5 linked questions. Smaller models can crash completely, reaching 0 on the longest chain. Code and web search degrade even more, because tool use and program synthesis compound mistakes across steps. So Figure 4 shows that training on composed data leads to stronger learning signals and higher accuracy. Composed queries mean linked subproblems that must be solved in sequence to count as correct. The left panel indicates accuracy on single-step AIME 24 rises more with composed training. The middle panel shows a much larger lift for two-step AIME 24. The right panel reveals the reward from composed data steadily surpasses the reward from single problem training. So, Table 1 summarizes how composed training and reward choices change accuracy. Training with 4 composed queries delivers the strongest multi-step average at about 43%. 2 composed queries gives the best single task boosts on AIME 24 and AIME 25, while keeping the overall origin average around 76%. Using the all-correct reward with 2 queries trails the 4-query mix on multi-step average, though it still reaches roughly 40%. The trend shows that adding composed problems improves original tasks and sharply lifts multi-step performance, because the model learns to allocate its thinking budget across linked steps. Alright, 2 takeaways stand out. Long horizon chains expose sharp accuracy collapse, revealing limits in effective reasoning length and token budget allocation. And R-horizon style composed training with verifiable rewards not only boosts multi-step performance, but also lifts single task accuracy, about plus 7.5 on AIME 2024. The broader implication is clear: evaluate and train across horizons, not just single steps. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.